In this lesson, we're going to look at some slightly more difficult probabilities that require the use of combinations. So if your sample spaces and your events are small enough, you can write them all out in order to determine your probabilities. However, a lot of times the sample spaces are simply too large to write out, and you need to just think about how many ways your desired event can occur and how many total outcomes are possible. So we may need to be using the combination formula to find either or both the numerators and the denominators of probabilities. Okay, so let's look at a first example here. We've got Jacobs and Johnson, Inc., an accounting firm, employs 14 accountants, of whom 8 are specifically CPAs. If a delegation of 3 accountants is randomly selected from the firm to attend a conference, what's the probability that 3 CPAs will be selected? Okay, so what we need to think about is the general idea of setting up a probability is, the number of favorable outcomes. You write this out, the number of favorable outcomes over the total, or the number of total outcomes. Okay, so favorable for this situation would be that 3 CPAs are selected. So for our numerator, we need to choose 3 CPAs. And for our denominator, the total amount is that we just, in general, have to pick 3 people. So choose any 3. Both of these, in this case, are going to require a combination. For the numerator, there are 8 CPAs total, and we're interested in choosing 3 of those. So out of the 8 CPAs, choosing 3. For our denominator, for our total, there are 14 total accountants at this firm, and we're selecting 3 from that pool. So you can see that the denominator is going to be larger out of that larger pool of people. Out of the whole 14, we need to choose 3. But on the top, we put the favorable outcomes. What would get us what we're specifically looking for, which would be choosing 8. Out of 8 of those, 3 CPAs. So for doing these, I'm absolutely going to use the calculator to do the combinations. I'm not going to do those by hand. I'm going to go into my math probability area and choose number 3. So 8 choose 3 is 56. And then I'm going to do a second enter and bring that back up. And I'm just going to go in and change this to a 14, that 8 to a 14 for my denominator. It's all that needs to change. So the denominator looks like it's 364. If you reduce that as a fraction, you will get 2 out of 13. And if you want to, you can go ahead and divide that out if you want to look at it as a percentage perhaps. It's about 15%. So there's about a 15% probability out of these 18 accountants to happen to pick all 3 who are CPAs. Pay attention to your online homework and your online quiz and test questions for exactly how they want you to give your answer as a fraction, as a decimal, or as a percentage, and how they would like you to round it. Okay, our next example says, electronic baseball games are manufactured by Timco Electronics and are shipped in lots of 24. Before shipping, a quality control inspector randomly selects a sample of 8 from each lot for testing. If the sample contains any defective games, the entire lot is rejected. What's the probability that a lot containing exactly 2 defective games will be shipped? Okay, so I need I'm going to collect my thoughts a little bit on this because there's a lot of information. So the one thing that I want to kind of make a note for is that if there are 2 defective in a shipment, remember the shipment has 24 total, so that would mean that there are 22 good in that same lot. Okay, so that might be helpful to just kind of lay that out there. And in order to ship, all 8 of the chosen have to be good. Right? Because even if they pick just one defective game, they're going to throw the whole lot out. So in order to ship, all 8 of the randomly chosen games have to be good. Okay, so we want to set up, again, a fraction. For our denominator, out of this whole 24, we're going to choose 8, right? So we're going to choose any 24 games. But the only way it's going to ship is if we choose all good games. Oh, sorry, I need to go back on this. Choose, I said this incorrectly. We have to choose any 8 games, specifically out of the 24. But on the top for the numerator, in order for it to ship, you're going to choose 8 good games. Right? The only way it ships is if all the ones that you happen to select are good. I'm going to start with the denominator. So in the denominator, out of the 24 total games, we're choosing 8. But for the numerator, we have to make sure we're choosing 8 good ones. And how many good ones are there? There are 22 good games in this particular lot, because we know 2 of them are actually bad. So out of the 22 good ones, we're going to choose 8 of those. Okay, so I'm going to do my 22, choose 8 for the numerator, and that is 319,770 over, I need to do a 24, choose 8 on the bottom, and that is 735,471. And then in order to calculate that out, we need to divide that out. So let's see, 319,770 divided by 735,471. So it looks like there's about a 43% chance of this happening. I'm going to skip down to the approximation, about 43%. And to see if that will reduce as a fraction, I'm going to go to my math, enter fraction. It does look like I could reduce that to 10 over 23. So depending on how they want that. So there's a 43% chance that you're going to ship this box that has 2 defective games in it by randomly choosing out 8 good games and not realizing that there are any bad ones in there.